Well, and you get into it was funny because one of the conversations I was having with the folks, the folks that managed the Pelosi building yesterday, was the difference between far infrared and near infrared. And so, we put a infrared filter on the glazing, right? So one of the things that this is occurring at this building, because it's naturally ventilated and very, very little mechanical heating and cooling, and they're using thermal mass and ventilation and such to kind of keep the ambient temperature appropriate for inhabitant comfort. What happens is in direct sun, it's different on the side of the building it's getting direct sun. It's different experience than maybe say the side of the building it's not. And when you look at infrared, there's the infrared that is like you're sitting in front of the window and the sun's hitting your shoulder and your shoulder's hot, right?
Mhm.
And that's the far infrared. The near infrared is the radiant heat that is just heating up the space, right? And so we put these infrared filters on films on glass or technologies in the glass that filter that out. So you're sitting in front of the window and your shoulder is not hot anymore, right? Or you put your hand on the surface where part of the surface is in the shade and you put your hand on the part of the surface that's in the sun. It's basically the same temperature. But that said, there's a radiant heat. That glass now is stopping that far infrared and it's itself getting warm and then radiating the heat gently inward, right? So it's funny when you start looking at how thermal conduction works and far infrared, near infrared, all of that stuff, and the fact that light carries heat, and that's what we're feeling when we're standing in the sun. It's a pretty complex thing.